a function f from x to y is bijective if it is both injective and surjective. So in other words, every element in the codomain is going to be paired with exactly one unique element in the domain. So every every element in the codomain Y is going to be the output of something, so surjective, and the output of only one thing, and that's the injective part. So let's see an example here. So let's say you have this set here, A, B, C, and D, and let's say this is our domain. And then let's say you have 1, 2, 3, and 4. And let's say you have the following function. And let's call this f. This was the codomain. Let's write out a table for this function. So f of A is 2, f of B is 1, f of C is 4, f of D is 3. And so now you need to check both properties. Is this function injective? Is this function surjective? Right? If you were to check each one individually, so let's say first injective, every element in the codomain, it has, at most one input that corresponds to it. So there's at most one line going into it. And so that is true. So 1 has one line, so that is at most one line. 2 has at most one line. 3 has at most one line. 4 has at most one line, right? Another way of looking at injective we had talked about is that if I know the output, I know the input. And that's the same as saying the one line. So of course here you can see it means that in this column here, all the numbers are different. All the elements here are different. I mean, in this case, they happen to be numbers, but they could be anything, right? So here, all of the elements are different. So if I get a 2, I know that it has to be an A. If f of x is 1, I know that x is B. If f of x is 4, I know that it's C. And if f of x is 3, I know that it's D. And so that does injectivity. Now, for surjectivity, we need to see that every element in Y is the output of someone in X. And that corresponds to every element here has to come from someone. And so you can see 1 comes from someone, 2 comes from someone, 3 comes from someone, and 4 comes from someone. Which again, if you look at this column here, it just says that all the elements of Y appear here. And that is the case. You have 1, 2, 3, and 4, and so they appear here. And so 1, 2, 3, and 4. So again, if you combine both of them, what we're saying in terms of the table here is that every element in Y not only needs to appear here, but it needs to appear once. So it must appear exactly one time. And if you think about that, that is exactly, like that means that every element of the domain is matched uniquely with an element of the codomain. So there's like an A corresponds to a 2, a B to a 1, a C to a 4, and a D to a 3. So here F is bijective. Let's see an example where it's not. So of course, if we take, let me do it in red. So let's say that we have A, B, C, D, and we have the set also 1, 2, 3, 4. So we have X and Y. And let's consider here A goes to 2, B goes to 1, C goes to 4, and D goes to 4. So what will happen here, so let's call this G, and let's do a table for it also. X, G of X. And so A goes to 2, B goes to 1, C goes to 4, and D goes to 4. So in this case, G is not bijective. Ooh. And so why not? You can check quite quickly here that two things happen actually. So this is neither surjective or injective. So it's not surjective because 3 is not appearing in this column here, and so no input gives you 3. So this is not surjective. And it's also not injective because if you look at 4 here, we do not know if it's either C or D. It's not a unique input that gives you this output. So two different inputs give the same output. So in this case, this is neither injective or bijective. But of course, you can just have one of these property fail, right? So, for example, you could just have something, let's do with 3 points. Let's say if X was this, and you had these 4 points here for Y, and let's say this was H, then in this case here, the table will look like this. So, so let's, of course, we need to define something. So let's do this and this. And let's take C equal to 4 here. So then A goes to 2, B goes to 1, and C goes to 4, right? So in this case, H is injective, but it's not surjective. So H is not surjective, and thus H is not bijective. So you can have an example where you fail only one. So you can have injective but not surjective. You can also have something that's surjective but not injective, and so on. So once again, and again, if you think about bijective in this way here, so every element in Y should be paired with exactly one element in X. So 1 is paired to B, 2 to A, 3 to D, 4 to C. Here this fails, 3 is not paired to anyone, and same thing here, 3 is not paired to anyone. And you can also have the issue where 4 is paired to 2 elements instead of 1, right? And so bijective means that every element in Y is going to be paired with exactly one unique element in X.